Hello guys, welcome back to LegoCode. Today let's practice a HackerRank question, LegoBlocks. So we are supposed to build a wall with W as the width and H as the height. And we can use the 4 different kinds of Lego blocks to build the wall. So these 4 different blocks, they all have the same height of 1, but with different width. So we have 1, 2, 3, and 4. So the question asks us to build the wall, and also it asks us how many ways we can use the Lego blocks to build the wall. Like if we want to build a wall with width and height and with a 2 and 2, we can use the 2 Lego blocks. So that is count as a 1 layout. Or we can also use 4 Lego blocks with width of 1. And this is also a 1 layout. So using these 2, we are at least have 2 layouts to build the wall. The question has one condition, that is, when we build the wall, we should only build a solid wall. So what is a solid wall? So in order to check what is a solid wall, let us to discuss what is an unsolid wall. So when that is an unsolid wall, we can find a straight vertical break that across all the bricks of the wall. So like this one. So if we can find this kind of break in the wall, then this is an unsolid structure or unsolid layout. And we only want to use, or we only want to count the number of ways to build the solid layout. Okay, so I have already decomposed the solution into 4 steps. The first step is to find out the number of the layouts or the number of ways we can build a wall in a single row. So how many number of ways we can build a wall when the height is only 1. And after we finish the step 1, we can extend to step 2. In step 2, we want to find out how many number of layouts there when we have to build a wall with edge rows. So it means here is a single wall row, and here we have multiple rows. When we are doing the step 1 and step 2, we are counting both the solid and unsolid layouts. But in step 3, we only want to find the bad layouts. So we want to find out the number of bad layouts of the edge rows. And then in the step 4, we can finally find out the good layouts, the number of good layouts. So this comes from the result of step 2 minus the result of step 3. Okay, now let's start with step 1. Find out the number of ways to build a wall in a single row when the edge is 1. So I want to use a list to keep track of the value of the number of ways. So the index, it means the width of the wall, and the value I want to put in the list is the number of ways. When the width is 0, there is no way we can build this wall, right? So we just put 0 here. And when the width is 1, we can only use this Lego block to build this wall. Here is 1. And the width is 2, we can use this Lego block or this one to build the wall. So we have 2 different ways. And when the width is 3, so when the width is 3, first let's use the 1. Take the 1, put 1 here, and then we'll remaining the parts with a width of 2. So here becomes a sub-problem. when the width is 2, we already know there are 2 ways to build a wall. So here we have 2 ways to build a wall. And besides that, we can first put a 2 here, and then remaining part is 1. And we already know that when the width is 1, there is only one way to build a wall. And in the end, we can use this Lego block to build a wall. So here we have 3 here. Here is just one way. So here in total, we have 4 different ways to build the wall. So when the width is 4, so first, let's put the 1 here, and the remaining part is 3. So now, when there's 3, we already know there are 4 different ways to build a wall. So here we have 4. And also we can have the 2 here, and the remaining part is 2. So the 2, it means we first use this Lego block, and then remaining part is 2. So let's check this. When the width is 2, there are 2 ways. So here we have 2. And we can also put 3 here. So remaining part is 1. And when the width is 1, there is 1 way. Also, we can use this Lego block here. So here is just 1 way. The width is 5. Now I want to use a function call to denote the number of ways we can use to build a wall. So when we want to find out the number of ways to build a wall with width of 5, it means first we can use the width of 1 Lego, and then we'll check. Okay, so 5 minus 1 is 4. So let's check how many ways there are when the width is 4. And also we can have 5 minus 2, or 5 minus 3, and 5 minus 4. These 4 blocks, it comes from these 4 fundamental blocks. Okay, so we will use the minus 1, minus 2, minus 3, minus 4 here. So we will have my f of 4. We have 8. It comes here, and then 4, and then 2, and then 1. So in total, we have 15 ways to build the wall. Next, want to build the width of 6. So when we are in this index, what we'll put in this index is like the sum of the previous 4 elements. So we'll sum up these 4 elements and then put it here. 29 here. So how about when the width is 7? So that is just the same logic. It comes from the 3, 4, 5 to 6, and we'll put it here in the index of 7. Okay, so that is how we find out the number of layouts there when the height is only 1. In the second step, we want to find out the number of layouts of edge rows. That means now we have multiple rows instead of just one single row. So let's assume we have a width of 3 and also the height is 2. So when the width is 3, in the first row, we have, let's check out from this list, we have 4 different ways to build the wall, right? So here we have 4 different ways, and here we also have 4 different ways. So in total, we have 4 square ways to build a wall. So in general, when we want to build the wall, the formula is like, so let's call the list as a T, capital T. It means the total with we combine the solid and unsolid structure in here. The number of ways to build a multiple rows is like T of W. So the W is the width, and to the power of height. And in step 3 and step 4, I will talk about them together. Okay, so in the step 3, we want to find out the number of bad layouts. Okay, so what is a bad layout? It means there is a straight vertical break in the wall. Okay, so let's draw that. Here is a wall. And the bad layout means we can find a straight vertical line here. So this wall, it divides the wall into the left part and the right part. And the left part, we have a width of, let's say it's I, and the total width is W. For the right part, it has a width of W minus I, right? And because it divides the wall into two parts, we can say that if we can find the number of ways to build the left part and multiply the number of ways to build the right part, okay, then we can find out how many numbers of ways to build the walls with a vertical straight break here. If we can find out number of ways to build the left part, the width is I, and multiply the number of ways to build the right part. And the width is W minus I. This is the number of ways to build this wall with a vertical straight line here. But we have many straight lines in the wall. Maybe let's say we could have another straight line here, and that is I prom. Actually, we will have a summation here to sum up all of the number of the bad layouts. So we'll have different I with I start from 1 to W minus 1. This part is the bad layouts. And again, we can take the number of the total layouts from the list T, and we can have the number of the total layouts. So we can have the total number of the number of total layouts and then minus the number of bad layouts. This, and then we can have the result we want. So we can have the number of good layouts. So we already know this. Take from the T, let's say if now the W is 5, then we know the number of total layout is 15. And also if the I is equal to 1, and then we also can take this one. So when the width is 1, so this side is also a wall itself. So when the width is 1, and then we know there's just one way to build a wall. And here we have 5 minus 1, that's 4. So when the width is 4, there are 8 different ways to build a wall. So it seems like all the variables here we can get a value from the T list, right? But here is a bug or some issues in this multiplication. So in this wall, let me draw the Lego blocks there. There may be some circumstances that we can find out two or more than just one vertical straight break in the wall. So we'll have the I here, and also we have I proms here. When we are counting the number of bad layouts, we will use the number of bad layouts of the left side and multiply the right side when I is equal to I. And also we will count these bad layouts again when the I is equals to I prime. So this is number of bad layouts, and multiply the number of right layouts. The bad layouts of this wall will be counted as this twice, but actually this is just one layout. It shouldn't be counted more than one. In this multiplication, we will count too many numbers of bad layouts. So to prevent this condition, this duplication, we will have a limitation on the left side. So we want to check that or ensure that whenever we have a new left wall, then we don't want to the left walls to be an unsolid one. We always want it to be a solid one, so that we cannot find any a straight vertical line or the break in the left one, in the left side. So that means we don't want to find out this one, and we just want the left side or the left wall to be a solid one. So that means this we cannot take the number of ways to build the left wall from this T array, right? Because in this T list we have both solid and unsolid structure. So now we will use another list. Let's call it S. It means solid. So this S. The index here means the width of the wall. Okay, so when the width is 0, there is no way to build a wall or a solid wall. And the width is 1. Okay, width is 1. So like this one, we can only use this LegoBlock, right, with width and height both 1 to build the wall. So there is only one way to build this wall. And when the width is 2, how do we count the solid wall here? Okay, and so we will use the formula here. Let me rewrite this formula. So that is so for width more than 1, the good structure or the solid structure will comes from this formula. Okay, maybe now you are a little bit confused, so I will now use an example to elaborate this formula. I would like to use this example to elaborate the formula. So in this example, we are required to produce the number of ways to build a wall when the wall has a height of 2 and width of 4. So in the red line here, or here, that is our formula. So that is the number of good structure when the width is W, that is equals to the number of total structures minus the summation of number of bad structures. So in order to calculate to width of 4, we have to start from width of 2. And okay, and before that, I will already have this total, the number of total structures list prepared. Be careful that the list is produced when the height is 2. Okay, so let's start from when the width is 2. So use this formula here. When this width is 2, so that is S2, S sub 2. That is equals to T sub 2 and minus the summation. So the I start from 1 to W minus 1, so that is 2 minus 1, that is 1. So here we have T2 minus S1 T1. So we'll have T2, so T2 equals to 4. And S1 T1, S1 here, that's 1, and T1 is also a 1. So the number of good layouts is 3 when the width is 2. Okay, so we can put 3 here. And after we finish the width of 2, then we can go to finish width of 3. So this formula again, the S3 equals to T3 minus the bad layout summation, and the I start from 1 to 2. The 2 comes from 3 minus 1. Okay, so we have T3 minus S1 T2 and S2 T1, and we have T3 now is 16, and S1 T2, so S1 T2, so that is 1 and 4, and S2 T1, S2 T1, so we have 3 and 1, so the answer is 9, so we can put 9 here. And when the width is 4, the formula is here, so S4 equals to T4 minus the bed layouts, so that is equals to T4 minus S1 T3, S2 T2, S3 T1, and then that is T4 is 64 minus S1 T3, S1 T3, so that is 1 and 16, S2 T2, that is S2 3 T2 4, 3 and 4, and S3 T1, S3 T1, so that is 9 and 1, so that is 9 and 1, so the answer is 27, so we can put 27 here, and this 27 is the answer to our question. So the 27 is the number of ways we can build a good layout when the wall is height of 2 and width of 4. Okay, now let's go to coding. Now let's start coding. And first of all, I would like to rename the variables N and M. That's really confusing to me. So this is H, the height, and M is the width. So I will rename it as a W. And then I want to have a modulo, and that is to 10 to the power of 9 and plus 7. So it comes from the return. In the description, it says we want to return the number of valid wall formations modulo 10 to the power of 9 plus 7. So I will have that variable. And then, so I will have a list. I'll call it row and initialize it as a 0. So for the list, I want to put the number of total layouts when the height is 1. Okay, so for the previous 4 numbers, I have to manually type in the value. But for comes to when the width is 5, I can use a for loop to calculate. So if W is greater or equal to 1, then and here now we can using the for loop start from when the width is 5. So for every number or for every width that is bigger than 4, and the number of layouts of that width is the previous 4 numbers of layouts, right? Like the width of 5, the number of layouts when the width is equals to 5 equals to the number of layouts when the width is equals to 4 and 3 and 2 and 1. Okay, so that is their summation. So that's I minus 1 and I minus 2, I minus 3, and I minus 4. And after that, I have to use the module. So we don't encounter the integer overflow problem. Okay, so maybe here we should also give a if else condition to check. Okay, so we have finished the step 1 to calculate the layout when the height is 1. So now let's go to step 2. We are going to calculate the number of layouts when the height is more than 1 or there are multiple rows. So first, I will like to have a total list, and that is the copy of the row list. Okay, so what I'm doing is like here now, if the row is equals to 0 and 1 and 2 and 4, and then first I will have a copy, right? 0, 1, and 2 and 4. So when the height is 1, the total is also the original number 0, 1, 2, 4. And when the height is 2, so start from this. When the height is 2, then I will use the every elements in the total number in the total to multiply the every elements in the row. So when that is 2, this one will comes to 4. That is 2 multiplied by 2, and this one goes to 8. And when the height is 3, then it means I use 2. So this one will multiply 4 by 2 again. So that is 8, and this one will goes to 32. Okay. So that is what I'm doing here. Okay, so now we already have the number of total structures in the total list. Then I would like to calculate the number of back structures. So in order to do that, we'll have a list, a solid list, and initialize 0 for every element in the solid list. And we know that when the width is 1, there is only one layout, right? And if the width is more than 1, then we'll have to use a nested loop. So why we use nested loop here? So the first loop is like, do you still remember in my previous example, if we want to calculate the number of good layouts, when the width is 4, we have to start from width of 2, and then goes to width of 3, and then goes to width of 4. So this WW means we'll start from 2 and 3. Okay. So for every width, then we'll have a unsolid sum. That is the summation in the formula, right? So when we have the width of 2, right, WW equals to 2, and then we'll have a 1 break. So that is the I equals to 1. That means there is a 1 straight vertical line there. And for the unsolid sum, we'll increase the unsolid sum by the number of unsolid layouts when there is a vertical line exists in I. Okay. So for the left side, we want to take the number from the solid list. And for the right side, we want to take that from the total list. Here we also like to have a module. Okay, it's unsolid sum. Okay, so after we have finished this nested loop, then we want to put that in here. So the number of layouts is the number of the total layouts minus the number of unsolid sum. And again, we'll want to use a modulo here. Okay, so our answer lies in the solid list. Okay, now let's run the code. Okay, pass and submit. Okay, yeah. Wow, that is such a real long video. Okay, so very thank you for if you watch the video until here. And then if you like my video, please leave a comment or leave a like or subscribe to my channel. That is a real big encouragement to me, so that I know I'm helping people, so I'm willing to make more videos. Okay, see you next time.